Elements of group 15 nitrogen family. Elements of group 15 nitrogen family. Okay, nitrogen family. Okay, nitrogen, phosphorus, nitrogen, phosphorus, arsenic, and antimony, arsenic, antimony, and bismuth are placed in group 15 of the periodic table. The five element nitrogen, phosphorus, arsenic, antimony, bismuth of this group are collectively called nitrogen family. It should be noted that it in no other group the transition from non-metallic to metallic character is so distinct as in this group. Free nitrogen occurs to the extent of 78% in the atmosphere. In the combined state, nitrogen is an essential constituent of all matters, both plant and animals, where it occurs in combination with carbon, hydrogen, and oxygen, mainly as proteins. The only mineral source of nitrogen is child saltpeter, NaNO3. The phosphate minerals and bone ash are the two important sources of phosphorus. Phosphorus is an essential constituent of all living vegetables and animal matters in many plants and animal tissues. Phosphorus occurs in the form of phosphoproteins. Okay, phosphoproteins as SV, that means antimony. Antimony are widely distributed in nature in the form of compounds. It is associated with the sulfide ores of copper, stainless, tungsten, iron, cobalt, and nickel. Bismuth. Okay, bismuth occurs in a small amount in minerals of silver, iron, and stainless. Nitrogen is related to sulfur, which is a member of group 15. The relationship between nitrogen and sulfur is known as diagonal relationship. Okay, electronic configuration. Electronic configuration. Electronic configuration. Electronic configuration. Okay, electronic configuration. What is the electronic configuration of group 15? That means nitrogen family. Okay, elements, symbol, atomic number, and electronic configuration. Electronic configuration. Electronic configuration. First atom is nitrogen. Nitrogen. First atom is nitrogen. Okay, nitrogen. Nitrogen. Symbol capital N. N. And atomic number 7. Electronic configuration 2, 5. R 1s2, 2s2, 2p3. Second is phosphorus. Second element phosphorus. Phosphorus. Symbol P. Atomic number 15. Electronic configuration 285. R 1s2, 2s2, 2p6, 3s2, 3p3. Next, arsenic. That is years. Arsenic and atomic number 33 and electronic configuration 2, 8, 18, 5 are 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p3. Next is antimony. Next is antimony. Next is antimony. Antimony. That is represented by Sb, and atomic number is 51. Atomic number is 51, and electronic configuration 2, 8, 18, 5 are 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 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 4s2, 4p6, 4d10, 4d10, 5s2, 5p3. Next is bismuth. Bismuth. Next is bismuth, and symbol Bi, and atomic number 83, and electronic configuration 2, 8, 18, 32, 18, 5 are 1s2, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 3d10, and 4s2, 3d10, 4s2, 4p6, 4d10, and 4f14, and 5s2, 5p6, 5d10, 6s2, 6p3, 6p3. Okay. The outermost electronic configuration is outermost. The outermost electronic configuration. The outermost electronic configuration is ns2, np2. Hence, these are the p black elements. N and p are non-metals, as Sb, antimony are metallite, and bismuth is metal. Okay. And nitrogen and phosphorus. Nitrogen and phosphorus is a non-metal. Nitrogen and phosphorus are non-metals. Okay. Nitrogen and phosphorus are non-metal, and arsenic and antimony. Arsenic and antimony. Arsenic and antimony are metalloid. Bismuth is metal, and bismuth is metal. Bismuth is metal, and bismuth is metal. Bismuth is metal. Bismuth is metal, as bismuth is metal. Okay. And arsenic and antimony. Arsenic and antimony. Okay. Arsenic and antimony are amphoteric. Amphoteric in nature. Okay. In nature. Okay. Nitrogen and phosphorus non-metals. Nitrogen and phosphorus non-metals. Arsenic and antimony metalloid. Arsenic and antimony are metalloid. Arsenic and antimony are metalloid. Arsenic and antimony are metalloid, and bismuth is metal. And bismuth is metal. Bismuth is metal. Okay. And arsenic and antimony are also amphoteric. Arsenic and antimony are also amphoteric. Okay. Next is occurrence. Occurrence. occurrence, okay, occurrence of group 15 elements, that means nitrogen family, occurrence of nitrogen family elements, okay. First point. First, nitrogen occurs in free state in the atmosphere and in the combined state as nitrate. Okay. Nitrogen occurs in free state. Okay. Free state. Nitrogen occurs in free state in the atmospheric. Free state in the atmospheric and in the combined state as nitrate NaNO3. That means chill saltpeter. Okay. Chilled saltpeter. Okay. Second point. Phosphorus occurs in combined state of phosphate. Phosphorus occurs in combined state as phosphate. Okay. Combined state as phosphate. Point A. Phosphorite 3Ca3PO4 whole twice CaOH whole twice. B. Hepatite 3Ca3PO4 whole twice into CaFCl2. Third point. Arsenic, antimony and bismuth. Arsenic, antimony and bismuth occurs as sulfide. Occurs as sulfide and oxide ore as given below. AS2O3, that is orpiment and AS4O6, that is arsenolite. Okay. Arsenolite. B point. Sb2S3 stibnite and Sb2O3 antimony blue and C. Bi2S3, that is bismuth glands. And Bi2O3, that is bismuth. Okay. Isolation. Third point, isolation. Isolation of group 15. Isolation of group 15. Group 15 elements. Isolation of group 15 elements. So that means nitrogen family. Nitrogen family. Okay. Then first point. Nitrogen is isolated from atmospheric nitrogen. Liquid air and fractional distillation separates out in nitrogen and oxygen fraction. Okay. Nitrogen is isolated from atmospheric nitrogen. Nitrogen is isolated from. Nitrogen is isolated from atmospheric nitrogen. Okay. Liquid air and fractional distillation separates out. Liquid air and fractional fractional distillation separates out in nitrogen and oxygen fraction. Okay. Second point. Phosphorus is isolated from the ore. Phosphorus is isolated from ore. Isolated phosphorus is isolated. Phosphorus is isolated from the ore. Ca3PO4 twice are bone ash by heating with silicon dioxide and coke. Okay. Bone ash also contains bone ash also contains Ca3PO4 whole twice. Ca3PO4 whole twice plus 3SiO2, that is 3CaSiO3 plus P2O5. P2O5 plus 5C, that is 2 phosphorus plus 5 carbon monoxide. Third point. Arsenic, bismuth and antimony. Arsenic, antimony and bismuth are obtained by roasting. Obtained by roasting of sulfide. Roasting of sulfide are and reduction sulfide ore and reduction sulfide ore and reduction of the oxide. Reduction of the oxide formed by carbon. Okay. M2H2 plus 7/2O2, that is M2O3 plus 2SO2 and M2O3 plus 3 it is 2m plus 3CO, carbon monoxide. Okay. Arsenic, antimony, and bismuth are obtained by roasting of sulfide and reduction of the oxide from the carbons. Okay, M2S2 plus 7 by 2O2, that is M2O3 plus 2S2. M2O3 plus 3C, 2M plus 3CO. Okay, next, physical properties of group 15 elements are physical characteristics of group 15 elements. Okay, physical properties of group 15 elements. Physical properties of group 15 elements. Okay, physical properties of group 15 elements. Okay, first is atomic number. Atomic number of nitrogen is 7, phosphorus is 15, arsenic is 33, antimony is 51, and bismuth is 83. Second point, atomic weight. Atomic weight. The atomic weight of nitrogen is 14.007, phosphorus is 30.974, and arsenic is 74.922, and antimony is 121.750, and bismuth is 208.980. Second is density, gram per cube semi. Gram per cube semi density. Okay, density of nitrogen is 0.809. Phosphorus is 1.823, arsenic is 5.73, and antimony is 6.62, and bismuth is 9.78. Atomic volume, cube semi. Atomic volume in cc, cube semi. Okay, then atomic volume of nitrogen is 17.3, phosphorus is 17.0, and arsenic is 13.1, antimony is 18.4, and bismuth is 21.3. Okay, atomic radius in angstrom. Atomic radius in angstrom. Atomic radius in angstrom. The atomic radius of nitrogen is 0.74, phosphorus is 1.10, arsenic is 1.21, and antimony is 1.41, and bismuth is 1.52. Ionic radius of nitrogen. Ionic radius of nitrogen. Ionic radius m minus q in angstrom. In angstrom is 1.71, 2.12, 2.22, 2.45, and 1.20. Ionization potential. First ionization potential in electron volt. Electron volt of nitrogen is 14.5, and phosphorus is 10.9, and arsenic is 9.8, and antimony is 8.6, and bismuth is 7.3. And 8 point, electronegativity. Electronegativity of nitrogen is 3, phosphorus is 2.1, arsenic is 2.0, and bismuth, antimony is 1.8, and bismuth is 1.7. And melting point of nitrogen. Melting point of nitrogen is minus 210 degrees Celsius. Phosphorus is 44.1, and arsenic is 814.5 degrees Celsius, and antimony is 630.5 degrees Celsius, and bismuth is 271 degrees Celsius. Boiling point, minus 195.8 degrees Celsius, of nitrogen, and the phosphorus is 287 degrees Celsius, and arsenic is 615 degrees Celsius, and antimony is 1380 degrees Celsius, and bismuth is 1450 degrees Celsius. Oxidation state. The oxidation state of nitrogen is 0, plus 1, plus 2, sorry, 0, plus 0, plus 1, plus 2, and minus 3, minus 2, minus 1, plus 3, plus 4, plus 5. Okay? And oxidation state of phosphorus is minus 3, plus 1, plus 3, plus 4, plus 5. And oxidation state of arsenic is minus 3, plus 3, plus 5. And oxidation state of antimony is minus plus 3, minus 3, plus 5. And oxidation state of bismuth is plus 3, plus 5. Okay? Good. Physical state. Okay? The general physical properties are discussed as follows. First is physical state. First is physical state. Physical state. First is physical state. Okay? First is physical state. At normal temperature and pressure, nitrogen is diatomic gas, while phosphorus is a soft waxy solid which vaporizes easily. But arsenic, antimony, and bismuth are comparatively hard solids with metallic shining. Okay? At normal temperature and pressure, at normal temperature and pressure, nitrogen is diatomic gas. Nitrogen is diatomic gas. Nitrogen is diatomic gas. Diatomic gas. Okay? While phosphorus is a soft waxy. While phosphorus is a soft waxy, solid which vaporized easily. Vaporizes easily. At normal temperature and pressure, nitrogen is diatomic gas, while phosphorus is soft waxy solid which vaporizes easily. Okay? But arsenic, antimony, and bismuth. Arsenic, antimony, and bismuth. Arsenic, antimony, and bismuth are comparatively hard solid with metallic shining. Okay? Metallic shining. Second point. Atomicity. All are polyatomic except bismuth. all are polyatomic. Polyatomic. All are polyatomic except bismuth. Except bismuth. Okay. All are polyatomic except bismuth. Nitrogen molecule is diatomic. Nitrogen molecules is diatomic. Nitrogen molecules is diatomic. Is diatomic. Diatomic. Okay. Whereas other forms tetraatomic molecules. Whereas other forms tetraatomic other forms tetraatomic molecules such as phosphorus, arsenic and Sb4. Okay. Antimony 4. Okay. Phosphorus, arsenic and antimony. Phosphorus, arsenic and antimony. Okay. And bismuth, all are polyatomic except bismuth. Nitrogen molecules is diatomic, whereas other forms tetraatomic molecules. Okay. Third point. Third point. Metallic nature. Third point. Metallic nature. Okay. Metallic nature increases with increase in atomic numbers. Nitrogen and phosphorus are non-metals. Arsenic and antimony are metallites, while bismuth is metal. Metals. Okay. Metallic nature increases with metallic nature increases with increase in atomic number. Increase in atomic numbers. Okay. Nitrogen and phosphorus are non-metals. Nitrogen and phosphorus. Nitrogen and phosphorus are non-metals. Arsenic and antimony are metallite. Arsenic and antimony are metallite. Arsenic and antimony are metallite, while bismuth is metal. Okay. Bismuth is metal. Next, allotropy. Okay. Allotropy. Fourth point. Allotropy. Now next, allotropy. If we consider active nitrogen as an allotrope, if we consider active nitrogen as an allotrope of nitrogen, then all these elements except bismuth are all these elements except bismuth, exist in allotropic form. Exist in allotropic form. Allotropic form. Okay, allotropic forms. Solid nitrogen exists in two allotropic forms. Solid nitrogen exists in two allotropic forms. Allotropic forms. Okay. Alpha nitrogen is that alpha nitrogen which contains cubic crystal structure. Which contains cubic crystal structure. Cubic crystal structure and beta nitrogen which contains hexagonal crystal structure. Hexagonal crystal structure. Okay. Phosphorus exists in 6 allotropic forms. Phosphorus exists in 6 allotropic. Forms like white phosphorus, red phosphorus, black phosphorus, violet phosphorus, brown phosphorus, orange phosphorus, okay? Orange phosphorus, okay? Allotropy. If we consider active nitrogen as an allotrope of nitrogen, then all these elements except bismuth exist in allotropic forms. Solid nitrogen exists in two allotropic forms. Alpha nitrogen, which contains cubic crystal structure, and beta nitrogen, which contains hexagonal crystal structures. Phosphorus exists in 6 allotropic forms like white phosphorus, red phosphorus, black phosphorus, violet phosphorus, brown phosphorus, and orange phosphorus. Okay? Orange phosphorus. Arsenic exists in 3 allotropic forms. Arsenic Exists in three allotropic forms. Exists in three allotropic. Exists in three allotropic. Exists in three allotropic. That is yellow arsenic, grey arsenic, and blue arsenic. Yellow arsenic, grey arsenic, and yellow arsenic, grey arsenic, and black arsenic, and black arsenic. Okay, black arsenic. Okay, yellow arsenic, grey arsenic, and black arsenic. Antimony exists also in three allotropic forms. Antimony exists also in three allotropic forms. Allotropic forms. Okay, antimony exists also in three allotropic forms, such as yellow antimony alpha, yellow antimony alpha, yellow antimony alpha, and black antimony or beta antimony, and black antimony or beta antimony, black antimony or beta antimony. Okay, black antimony or beta antimony, and amorphous or explosive antimony, and amorphous or explosive antimony, explosive antimony. Okay, next point, atomic radius. Okay, atomic radius. The increase in radius from nitrogen to bismuth is due to increase in outermost orbit. The increase in radius from phosphorus to arsenic is small due to d block contraction. Arsenic comes after d block element, and a small increase in radius from antimony to bismuth is due to lanthanide contraction effect. Bismuth comes after lanthanides. Okay, the increase in radius from nitrogen to bismuth, the increase in radius from nitrogen to bismuth, is due to increase in the outermost orbit, okay. Atomic radius. The increase in radius from nitrogen to bismuth is due to increase in the outermost orbit. The increase in radius from phosphorus to arsenic, the increase in radius radius from phosphorus to arsenic, from phosphorus to arsenic is small due to d block contraction. Is small due to d block contraction. Due to d block contraction. Okay. Arsenic comes after d block elements. Arsenic comes after d block elements. Okay. D block elements, and small increase in radius from antimony to bismuth. From antimony to bismuth due to lanthanide contraction effect. Due to lanthanide contraction effect. Okay. Bismuth come after lanthanides. Bismuth comes after lanthanides. Okay. Element atomic radius. Nitrogen, phosphorus, arsenic, antimony, bismuth. Nitrogen, the atomic radius of nitrogen is 0.74, phosphorus is 1.10, arsenic is 1.21, antimony is 1.41, and bismuth is 1.52 angstrom. Okay, 1.52 angstrom. Okay. Ionization potential, 6 point. Ionization potential, IP. Ionization potential. What is ionization potential of group 15 elements? That means nitrogen family elements. Okay. As we move down the group, the value of ionization potential decreases gradually due to increase in radius. The decrease in ionization potential from antimony to bismuth is small because bismuth has a high effective nuclear charge. Okay. Ionization potential. As we move down the group, the value of ionization potential. As we move down the group, the value of ionization potential, decreases gradually due to increase in radius, the decrease in ionization potential, from antimony to bismuth, from antimony to bismuth is small because bismuth has a high effective nuclear charge. Bismuth has a high effective nuclear charge. Effective nuclear charge. Okay. Ionization potential. As we move down the group, the value of ionization potential decreases gradually due to increase in radius. The decrease in ionization potential from antimony to bismuth is small because bismuth has a high effective nuclear charge. 7.7 Electronegativity. Electronegativity decreases gradually due to increase in atomic size. Electronegativity decreases gradually due to increase in atomic size. Okay. Electronegativity decreases gradually due to increase in atomic size. Okay. Electronegativity decreases gradually due to increase in atomic size. Okay. 8.8 Density. As we move down the group from nitrogen to bismuth, density increases. As we move down the group from nitrogen to bismuth, density increases. Okay. 9 melting point and boiling point. Melting point and boiling point. Melting point and boiling point. Okay. Melting point increases from nitrogen to arsenic. Okay. Melting point increases from nitrogen to arsenic. Melting point increases from nitrogen to arsenic. Okay. Melting point increases from nitrogen to arsenic and then decreases. This is due to tendency of Sb and bismuth, antimony and bismuth, of forming three bonds instead of forming three bonds instead of five. Okay. Instead of five, due to inert pair effect. due to inert pair effect, due to inert pair effect, due to inert pair effect. Okay, that is why a weak attractive force occurs. That is why a weak attractive force, that is why a weak attractive force, that is why a weak attractive force occurs in antimony and bismuth in solid state. In solid state, boiling point increases gradually. Boiling point increases gradually. Boiling point increases gradually with increase in atomic weight. With increase in atomic weight from nitrogen to bismuth. Okay. Next, oxidation state. 10th point. Oxidation state. Okay, oxidation state. Okay. Next point, oxidation state. Okay. Since all elements of group 15 possess ns2np3 electronic configuration in outermost orbit. Okay. Since all the elements of group 15 possesses, all the elements of group 15 since all the elements of group 15 possesses ns2np3 electronic configuration in outermost orbit. Electronic configuration in outermost orbit. Okay. Hence they possesses +3 and +5 states. Hence they possesses +3 and +5 states as common. On moving down the group, the +3 oxidation state becomes the +3 oxidation state becomes more and more common. And stable while +5 state less stable. This is due to inert pair effect. This is due to inert pair effect. Okay. This is due to inert pair effect. Okay. Nitrogen and phosphorus show oxidation state from -3 to +5. Nitrogen and phosphorus. Nitrogen and phosphorus. 1 minute. Nitrogen and phosphorus. Nitrogen and phosphorus. Nitrogen and phosphorus show oxidation states from -3 to +5. Whereas arsenic, antimony, bismuth, and bismuth show oxidation states of +3 and +5. The stability of +3 state increases from nitrogen to bismuth. Okay, the stability of a 3-state increases from nitrogen to bismuth, and +5 state, and +5 state decreases from nitrogen to bismuth. For nitrogen most stable oxidation state is +5 NO3, and for bismuth most stable oxidation state is +3 BH3. Electronegativity of these elements is as electronegativity of these elements is as nitrogen, phosphorus, arsenic, antimony, and bismuth. 3 phosphorus is 2.1, arsenic 2.1, 2, and antimony 1.8, and bismuth 1.7. The electronegativity of hydrogen is 2.1. Hence, the electronegativity of hydrogen is 2.1. Hence in AS3, SbS3, BiS3, oxidation state of arsenic, antimony, and bismuth, is +3, not -3. Okay, the different oxidation state you can show, and group 15 elements can be summarized with examples of following table. You can show oxidation state of group 15 elements: -3 ammonia, Mg3N2, and phosphorus, PS3Mg, 3p2 and minus 2 oxidation state N2H2 and P2H2 minus 1 oxidation state NH2OH and 0 oxidation state is N2 phosphorus tetraphosphorus dinitrogen and plus 1 nitrogen oxide N2O and H3PO2. Okay, plus 3 oxidation is formed due to np3 electron. Plus 3 oxidation is formed due to np3 electrons of NH2np3 not pair effect and plus 5 state is due to involvement of all the electrons of NH2np3. Next point, nature of bonds in compounds. Okay, nature of bonds in compounds. Nature of bonds in compounds. Okay, compounds in almost all the oxidation state are covalent. Oxidation state are covalent. Okay, compounds in almost all the oxidation states are compounds. Compounds in almost all the oxidation states, all the oxidation states are covalent, and hence bonds are covalent, and hence bonds are covalent. Okay, in nitrite phosphides, phosphides X minus 3 is ionic, and in BiF3 bismuth trifluoride is Bi plus 3 is ionic. Okay. Among all the elements, only nitrogen form a negative ion since it is the smallest and the most electronegative elements. However, covalent compounds of nitrogen are more common. The electronegativities of the remaining elements are so low that they generally form covalent compounds even with highly electropositive elements. Thus, the bonding in metallic phosphides and arsenides is largely covalent. Okay, next electron donor. Okay, nitrogen cannot act as a receptor because it has no d block orbitals. Other elements do act as a electron acceptor because of presence of vacant d orbitals. Nitrogen cannot act as a receptor. Nitrogen cannot act as a receptor. Okay, because it has no d orbital. It has no d orbital. Other elements do act as electron acceptor. Because of presence of vacant d orbitals. Because of presence of d orbitals. 14 points. Catenation. Okay, this property is very lower in these elements in comparison to carbon. This is due to gradual decrease in bond energy with increase in atomic number. Okay. And next point, 14 point, 15 point, 15 point. Catenation. This property is very lowered in these elements. This property, this property is very lowered. This property is very lowered in these elements. In comparison to carbon. In comparison to carbon, this is due to gradual decrease. This is due to gradual decrease. This is due to gradual decrease in bond energy. Bond energy with increase in atomic number. With increase in atomic number. Okay. Next point, 15. Tendency to form multiple bond. Tendency to form multiple bond. Tendency to form multiple bond. Okay. Nitrogen form multiple bonds like N triple bond nitrogen, N triple bond oxygen, due to pi overlap. Due to PP overlap, other do not. Okay. Nitrogen forms multiple bonds. Okay. Multiple bond exist in nitrogen is due to its small size. Okay. Phosphorus, arsenic, and antimony forms tetrahedral molecules in elemental state. Phosphorus and arsenic form p pi and p pi d pi multiple bonds. Multiple bonds of phosphorus are seen in compounds like POX3 and Rn double bond PX3. Okay. And you can show also as like this the figure. Then this is the phosphorus and phosphorus. Okay. This is as like this. Okay. This is N2 mark of nitrogen triple bond nitrogen. Okay. And P4. Okay. Due to large size of phosphorus, pi bond is not possible due to PP overlap, and so P2 does not exist. Okay. Next is chemical property and compounds of group 50 elements.